Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I am Jeetendra Dixit. Here is my profile. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. I teach mathematics and we were doing transformation of graphs. So this is second session of transformation of graphs. So 4 types of transformations we have already done. And today I'll continue the other transformations, all right? But before starting, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform. And you can have 2 types of subscriptions on Unacademy, Plus subscription and Iconic subscription, all right? So I'll tell you the details of both the subscriptions and their prices. So when you take Plus subscription, then you get access to daily live classes of all the JEE educators, all means all physics, chemistry, and maths. You can all India's top educators are teaching on the platform, so you can follow any educator of your choice, and all these courses are well structured. So everything is pre-planned. You can see the schedule of all the upcoming lectures in well advance. All right, and this live classes are very interactive. You can ask your doubts during the live session. You can participate in poll. So many features are there. To see these features, I mean, you can attend special classes also without getting the subscription. So just go and attend special classes on the platform. Just download the Unacademy's learning app and attend special classes. Every day, a lot of special classes are taken by top educators. So you just need to make your account and start special classes. All right. Now, these are the subscription charges, 38,500 for 1 year, and after 10% discount, you'll have to pay 34,650 only. So use my code JEET1 to get 10% discount, and this list you can see as for subscription charges without discount, and after discount it will be like this. All right. So these two are the best economically better packages for 1 and 2 years. All right. So subscribe for 1 or 2 years. And next is Iconic subscription. So as I was telling you, there are 2 types of subscriptions. One is Plus, another is Iconic. So in Iconic subscription, what happens is, 1 minute. So in Iconic subscription, you get all the benefits of Plus, all right? And apart from that, you get a personal coach who will guide you throughout all the topics, throughout your preparation for all top exams like JEE Advanced, JEE Main, and BITS. All test analysis will be done in a personalized manner. Your personalized feedback will be given to you to improve your time management and exam approach. Your study planner will be customized to you, and bi-weekly reviews will be given to highlight your progress. Okay, so these are the features of Iconic subscriptions, and here is the price list. So you'll have to pay 50,000 without discount, but use this code 10 to get 10% instant discount. For 1 year it is 50,400. Similarly for 2 years it is 77,400. Okay, so you can download this Unacademy's learning app from Play Store and start learning. All right, start attending these special classes from today only. So we have already done transformations. This was the first transformation which we did, replacing y is equal to minus y. Then the second transformation we did was x, replacing x is equal to minus x. Now the third transformation was this one, replacing x is equal to x plus a in any equation, or x minus a, x plus a or x minus a. Then the last fourth transformation was replacing y is equal to y plus minus a. Okay, so after that we'll continue today. Just let me check something. Perfect. Okay, now see what is our fifth transformation. So fifth transformation is when you replace x by ax. That means you multiply some constant to x. Then what happens? All right. So if you have this equation y is equal to fx, and you do this transformation, y is equal to, sorry, x is equal to you replace x by ax, the new equation will look like this: y is equal to f of ax. All right, f of ax. Now see what happens when you replace x by ax. So a might be more than 1, a might be less than 1. Okay, So depending on the value of a, let's take a more than 1 first of all. Okay, so first case, when a is more than 1. When a is more than 1, then what will be the change? See, domain of fx, if you remember, now we were taking this graph. I'll revise you first. We were taking this graph of fx, y is equal to fx. Okay, in this we took the domain from minus x1 to plus x3, right? This was the domain. See what will happen in this case. Domain is x is belonging to minus x1 to x3. Now in this case, to find the domain, ax should be between this interval minus x1 to x3, and a is a positive number. A is a positive number. I'm not taking negative because if a is negative, that means you can do two transformation. First replace x by minus x and then replace a by x by ax. Okay, so you can divide by a, so it is going to be x3 upon a and minus x1 upon a. So if a is more than 1, if a is more than 1, then what will happen? You can see this interval will contract. Which interval? This minus x3 to minus x1, sorry, minus x1 to x3. This was the original domain. If a is more than 1, then this is going to contract. This x1 minus x1 will become minus x1 upon a. Say is 2, so it will become minus x1 by 2. So this point is 0, so it will come close to 0. Okay, and x3 will become x3 by 2, so this will become x3 upon a. Okay, the whole graph will contract. Its domain is contracting, the whole graph will contract. Okay, but if a is more than 1, but if a is more than 1, a is more than, sorry, a is less than 1, then what will happen? Then this was your minus x1 and this was your x3. So whole graph in this case will expand because x3 upon a will be greater than x3, right? Say a is 1 by 2. Okay, say a is 1 by 2. That means you are doing x, you are replacing x by 2. So whole graph will expand. The domain will be of double length, and this point will become minus x1 upon a. Okay, I hope you are getting this point. So let me change the graph also here. This was the graph. This was the graph like this. This is the original graph. Okay. Oh, I'm sorry. This was the graph, right? So this graph of y is equal to fx will contract. Okay, if a is more than 1. So how this new graph will look like? Let me plot. So when this graph will contract, it will look like, range will not change, range will remain same. Okay, and it will pass through this point. This point on x-axis will remain same. F of 0 will remain same, whether you put 0, x is equal to 0 in this, or x is equal to 0 in this. Okay, they both will give you same value. So this point is going to be same. Okay, it will pass through this, and because it is going to contract, so it will achieve the maximum last value soon at x3 by a only. Okay, so after contracting, this graph will look like this. Shape will remain same. It will be like this only. Okay, the only thing is that now all these values will be achieved in a small interval. Now what will happen when it expands? So to make the expanded graph, first let me make the original graph. So this was the original graph. Okay, this is your y-axis. Okay, so after expanding, this graph will, okay, y range will remain same. There's no change in the range. Now again, this point will remain same, the point on y-axis. Okay, all these graphs will cross y-axis at the same point. Now it has expanded, so all these values will slowly increase. Okay, will reach to the same height, same y coordinate in the end, but that point will be x3 upon a. So graph expands. Okay, when a is less than 1, that means when suppose you are plotting the graph of say sine 2x. then the graph of sine x will contract. If you're plotting the graph of sine of x by 2, the graph will expand. All right. The same intervals of sine x will be of double length. So I'll give you the examples, you'll understand it in a better way. One minute. Suppose we need to plot the graph is equal y is equal to sine 2x and y is equal to sine x by 2. Okay. See what happens. This is a very good example to understand. Okay, so let's make a small part of sine x. Say this is our sine x. You can make only this part, or maybe one more. So this is 2 pi, up to 2 pi. Okay, leave it here. And the graph continues. All right. Then you know how to continue the graph. Okay, so this point is now 2 pi. This point minus 2 pi, minus pi. This point is pi, and this point is 2 pi. Now see what happens when we need to plot the graph of first y is equal to 2x. I'll plot this with yellow color. So as I told you, the graph will contract when you are replacing x by 2x. Okay, you'll get y is equal to sine 2x, and graph will contract. So this point pi will become, just divide all these points by 2. Okay, all these points by a. So this is going to be pi by 2 now. This is pi now. This is like this, and so the whole graph of sine x, the shape will remain same. Okay, and the range will remain same, right, like this. Okay, now you can see this is the contracted graph, and one more part will come. If you want to plot up to 2 pi, it will look like this. Are you getting this point? Here also. Okay, so you can see the wave will continue like that only. The period of this, if you know the period of the function, then the period of the function will become half. All right. Now it is, I mean, repeating its values with the interval of length pi. Okay, so that. And what happens when you plot the graph of y is equal to this one? So I'll make the different x-axis. This is your x-axis. Okay, so let's plot it here. In this case, the length will double. Okay, now all these points will become, just divide by 1 by 2. Okay, see, when you're plotting the graph of y is equal to ax, f of ax, and this was the point x1. Okay, in this graph, what this will where this point will become, I mean, what will be the coordinate of this point in the graph of y is equal to ax, f of ax. Okay, so this point becomes, in the graph of, when you plot the graph of f of ax, shape remains same. This point becomes x1 divided by a. Okay, x1 divided by a. Shape remains same. This point becomes x1 divided by a. That is the only change you need to do. So if I'll tell you, see, you need to plot the graph of sine x only. Okay, but the length is going to double now. So it's like this. What is this point now? This point was pi. Now it is divided by 1 by 2. So now you can see this point is 2 pi. And this point is minus 2 pi. So I hope you have got it. Okay. So it will expand. Let me give you another example. So another example is, you need to plot the graph of fractional part of x by, say, 3. Okay. So that means if you know the graph of y is equal to fractional part of x, you have replaced x by 3. You have multiplied x by 1 by 3. Okay. So what you need to do, I'm plotting this graph, final graph, okay, directly. Now I'm telling you an important point. No need to plot the base graph, plot directly fractional part of x by 3, because only you need to change the points on x-axis. There's no other change. There's no change in the coordinates of coordinates along y-axis. That means there's no change in the range. Maximum value will remain same, minimum value will remain same. The only change is in the change of coordinates. So you just plot the graph of fractional part of x, okay? Whatever the graph of fractional part of x was, just plot that graph only, okay? Just plot that graph only, okay? Nothing to worry. See, I plotted those points. Okay. The only change you need to make is this point was 1, okay? Now this, whatever was the point x1, now that will become x1 divided by a. A is 1 by 3. So you can see every point will become 3 times of the original point. So this point was 1, now this will be 3 into 1. So 3, this point will become 6, okay? This point will become 9. This point will become minus 3. This point will become minus 6. Got it? So that is the only change you need to make. Rest everything is same. So I hope you have got it, okay? Yeah. And what if if I ask you to plot y is equal to fractional part of, this was fractional part of x by 3. Now plot the fractional part of 3x, all right? Let's plot this. So that means you are replacing x by x by 3x, all right, in the graph of fx. So this graph will become f of 3x. So all the points x1, the point which was x1, will now become x1 by 3. Okay, I'll tell you what I'm saying. Just plot the graph of y is equal to fractional part of x. Nothing to worry. Graph is going to contract or expand. Graph is going to contract, all right? So like this, like this, like this, like this, right? Wait a minute, sorry. Wait a minute. Y is equal to, we are plotting 3 times of fractional part of 3x, all right? So, okay, this is origin. To better clarity. Like this, all right? Plot the graph of fractional part of x. What is the change? Okay, I'll tell you the change. The change is that this value will remain same. This value is 0, 1 only. These values will change. So this value originally was 1. Now it will become 1 by 3. Now it will become 2 by 3. Now this will become 3 by 3. That means this is 1. This is 4 by 3. This is minus 1 by 3. So divide all the numbers on x-axis by a. And a is 3 in this case. Got it? So that is the change you need to make. I hope you have got it. So we will move to another transformation. Just wait for a moment. Let me check the streaming. All right. So now let's discuss the sixth transformation. Okay, sixth transformation. So what is the sixth transformation? Replacing y by ay. Okay. So replacing y by ay means the new equation will become y is equal to fx will become y ay is equal to fx, or you can say y is equal to fx upon a. Okay, y is equal to fx upon a. So multiplying a to y means dividing fx by a. Okay, so in this way it is easy to understand. So we will see that we need to plot the graph of y is equal to fx upon a. Okay, so a is more than 1, you can see if a is more than 1, the graph will contract, and if a is less than 1, the graph will expand, but along y-axis now, along y-axis. Okay, along y-axis. So I'll give you the idea. It is easy to understand in this way, all right? Say this was your graph. Okay, say this point is y2, and this point is y1, because it is going to expand or contract along y-axis. So I'm giving you these points now, minus y1 and plus y2. There's no need to write these points, minus x1 plus x3, but I'm writing it. Okay, so now first transformation when a is more than 1. When a is more than 1, then graph will contract. Okay, in this case, you can see fx is divided by, so all the values will be divided by a. Say a is 2, then all the values will become half. Okay, these coordinates will remain same in this case. Okay, so graph, if a is more than 1, will become like this. All these values will reduce by a times. Okay, so what is this value? This value will be y minus y1 upon a, and this value will become y2 upon a. Okay, when a is more than 1, when a is more than 1, when a is less than 1, when a is less than 1, when a is less than 1, the graph will expand. So graph will be like this. That means if you're dividing fx by 1 by 2, so it will become 2fx, right? Okay, this value will become y2 upon a, this value will be y1 upon a minus y1 upon a, where a is less than 1. A is less than 1 and obviously more than 0. A is a positive number. Okay, so if you divide fx by a number which is more than 1, the graph will contract, and if you're dividing fx by a number less than 1, that means you're multiplying fx by a number which is more than 1. Okay, the graph will expand along y-axis. I'll show you the examples, you'll understand it easily. So see the examples first. You will understand the examples easily. See this. Suppose we need to plot the graph of y is equal to 3 sine x, all right? 3 sine x. See. So what you need to do is, just plot the graph of sine x. See, this was the graph of sine x. Okay. Let's take this one on this much only. Okay. Minus 2 pi to plus 2 pi. Now, when you multiply sine by 3 units, okay, this was the graph of sine x. Now you are plotting 3 sine x, so the whole graph will go up. All values will become 3 times, because you have divided sine x by 1 by 3, so it has become 3 sine x. So, or you can say you are replacing y by 3 in y is equal to sine x, right? So if you're dividing y by 3, then whole graph will expand. Okay, it will become like this. So it's very easy to understand that range of this will become plus 3 minus 3 to plus 3, right? The whole graph will, and pi, at pi it will be 0, at 2 pi it will be 0, so these points will remain same. If you need to plot, let's say first, second is if you need to plot y is equal to sine x by 2, then how would this graph look like? See the yellow graph. So this is going to be contracted graph, because we are dividing sine x by 2. All right, this value will become 1 by 2, and this value will become minus 1 by 2. So this is minus 1 by 2, and this is 1 by 2. This yellow graph is graph of sine x by 2. So I hope you have got it. Okay, so when you multiply and divide some constant to a, that means you are dividing and multiplying the same constant to fx. Okay, accordingly, a is more than 1 or less than 1, graph will contract or expand along y-axis. Okay, the coordinates on x-axis will remain same. Okay, those points will remain same. So you just plot the original graph and just change the range. That's it. Now let me give you some example to plot. Okay, so plot these three graphs. Okay, so start doing it. Meanwhile I'll plot coordinate axis. I'll also make the base graph so that for you it will be easy to plot the transformed graph. Okay, this is the graph of y is equal to x square. All right, so let's do it. The first one, because you have multiplied 2 to fx x square, the whole graph will expand along x-axis. Okay, so all these values will be double now. Okay, so 2x square, double these values. Okay, double these values. The whole graph will be above this, like this. This is y is equal to 2x square. Are you getting this? The graph is expanded along because there's no graph along negative y. Otherwise, that would have been gone down. Okay, down. So this is the graph of 2x square. You're dividing y by 2, or that is same as multiplying fx by 2. Okay, so dividing y by 2 means expansion along y, or similarly multiplying fx by 2 is again expansion along y. Now the second one. You can directly plot the graph of y is equal to fractional part of x and change the x and y coordinates. That's it. See, you need to plot this graph. this fractional part of x. All right. Now what is this point is going to be? This, because you are multiplying x by 2x. Okay. So this point will become 1 by 2. You need to divide this. Okay. This point is 1 by 2. Graph will contract along x-axis and expand along y-axis because we are multiplying it by 2. So this point will become 0 comma 2. Okay. So it is expanding along y-axis and contracting along x-axis. Have you got this point? Because you're multiplying x by 2 and dividing y by 2, right? Are you getting this point? You're multiplying x by 2 and dividing y by 2. That's why it is expanded along y-axis but contracted along x-axis. Expanded along y-axis and contracted. That is going to be the graph. Okay. This point is 1 and this point is minus 1 by 2 and this point is minus 1 and so on, 0 comma 2. Now 2 sine pi x. Let's plot it. Let's do the same thing here. The graph of y is equal to 2 sine pi x. All right. So you need to plot the graph of sine x, okay? And because you have multiplied sine by 2, so it is going to expand along y-axis. And because you have multiplied pi to x, so it is going to contract along x-axis, okay? Just for your information. So this point originally was pi, now it will be divided by pi. So pi upon pi is 1. This point will become 2, all right? Yes, this point is minus 1. This value will be 2 and this value will be minus 2. So this is the graph of 2 sine pi x. Have you got it? So it is contracted along x-axis and expanded along y-axis. That's the change. Now I'll give you an next example. Y is equal to, say, minus of ln of 2 minus 2x. All right. See this graph. You need to plot this. So I'm slightly increasing the difficulty level. A lot of transformations are involved in this. See if you can plot it. Try this one. Meanwhile, I'll plot the x and y axis. All right. So let's begin with this. Y is equal to ln x. Then you can plot the first transformation is replacing y by minus y. So you'll get y is equal to minus ln x. All right. Then the second, this can be written as ln of uh, 2 times of 1 minus x. All right, like this. Yeah. Then what you can do is you can replace x by minus a. Replace x by minus x. You can see. Uh, You can replace x by minus x. You'll get y is equal to this equation ln of minus x. So you've got this minus x, but you need, if you take minus sign common, it is x minus 1, okay? So further you need to replace x by x minus 1. So this equation will transform to y is equal to minus of ln of minus of x minus 1. Okay, but I missed something. There was one transformation because now you can't bring this 2. So what you needed to do was replacing x by 2x first before this transformation, okay? You have to replace x by 2x first. So graph will contract along x-axis, okay? So that is the transformation which you'll have, which you can't do after this. So first do that. What is that transformation? You need to replace x by 2x. So now this graph will become y is equal to minus of ln of minus 2x, all right? Now you can do the last transformation. So last transformation is, that will give you the answer. Y is equal to replacing what? Replacing x by x minus 2. So now final graph is going to be y is equal to minus of ln of minus 2 times of x minus 1. I'm sorry, x minus 1. X minus 1. So you can see this is same as writing minus of ln of, if you multiply this minus 2 inside, this is 2 minus 2x, okay? So have you got this equation? Yes, that is the final answer. So let's do it one by one, stepwise. So this is your ln x, first one. Now second is minus ln x. So the graph will be image of the original graph about x-axis. This is minus ln x, all right? Then minus of minus ln x, right? Ln of minus x. So x is replaced by minus x in this graph, okay? So this graph will transform image of this graph about y-axis. This one, have you got it? Now you're replacing x by 2x. The whole graph will contract. This point is 1 minus 1 comma 0. So the only, what you need to do is you need to change this point, coordinate of this point. That's it. Graph will look like the same. So now this point will become, what is this point? This point is now minus 1 by 2 comma 0. You can see if you put minus 1 by 2 in this, x is going to minus 1 by 2, it is going to be ln1 is 0, right? So that is the only change, okay? This point, which is minus 1 comma 0 in this graph, will become minus 1 by 2. There is no change in the, I mean, the graph will look like same. I mean, obviously there are change in values, but it will look like the same previous graph. Now the final transformation is replacing x by x minus 1. The whole graph will shift by 1 unit, okay? So 1 unit. So this line is, this line you need to plot is x is equal to 1 line, okay? So x is equal to 1 line. Now it's minus 1 by 2. That point will become plus 1 by 2. It will shift by 1 unit. So graph will look like this. Okay, this point is 1 by 2 comma 0. So this is the graph of y is equal to, this y is equal to minus of ln of 2 minus 2x. I hope you understood this, right? This was the final transformation. I hope you enjoyed this and all these steps are clear to you. Let me give you another transformation. You need to plot the graph of y is equal to So plot the graph of this. Although it's a rational function, but what I want you to do is, you know, the graph of y is equal to 1 upon x. So I want you to plot that graph using the base graph as y is equal to 1 upon x. So this is the graph of y is equal to 1 upon x. You need to transform this, okay? Transform this one. So look at these steps. First, simplify this. What kind of transformations you need to do to find the graph of y is equal to 3x minus 5 upon 1 minus x. All right. So try that. You can simplify this. You can write this 3 times 3x minus 3 minus 2 divided by 1 minus x, and after dividing it, you'll get minus 3 plus 2 upon x minus 1. Okay. So now you can figure it out. All right. So I'll write these steps. First, you need to plot y is equal to 1 upon x. Then you can do y is equal to 2 upon x. This is step you can do, replacing the y by 2, right? So graph will expand along y-axis. Then you can replace x by x minus 1. So you'll get y is equal to 2 upon x minus 1. Then you can replace y by y plus 3. Okay. So you'll get this y plus 3 is equal to 2 upon x minus 1. Okay. So 1, 2, and 3 transformations. Okay. So I'll plot this graph 3 times coordinate axis. 1, 2, and here will be our final graph. Okay. So first you need to do is 2 by x. So it graph will expand along y-axis. So values will double, right? So you won't be able to see the change, but all the values, if you plot together, then you can see the change. If you plot the graph of y is equal to, like here, if you want to plot, then graph will be like this. Like this. This will be the graph. Okay, it will go like this. Now, so this is the graph of y is equal to 2 upon x. Now you need to replace x by x minus 1. So the whole graph will shift towards left by 1 unit. Sorry, towards right, I'm sorry. Towards right by 1 unit. So this point is 1 comma 0. So shift this original graph by 1 unit. So if you do so, then after transformation graph will look like, yeah. So this part will be like this only, and this part will be like this only. Okay, so this is y is equal to 2 upon x minus 1. Finally, you need to replace x y by y plus 3. So the whole graph will go down. Okay, and the whole graph will go down by 3 units. So what am I doing is I'm taking x-axis here. Okay, this is your x-axis, and let's plot this line again. So final graph is with yellow line. Okay, whole graph will go down You need to plot this line as well. Okay, this was x is equal to 1 line, this is y is equal to minus 3 line. Okay, so this graph will come down like this. Okay, like this. You can see this value is going to be, if you put 0 in this equation, this is going to be is minus 5, right? So this y is equal to, this point is 0 comma minus 5. Okay, this is 0 comma 0. And this value, if you need to find, you need to put y is equal to 0. So you'll get x is equal to 5 by 3. This point is 5 by 3 comma 0. Okay, so in this way you can find these values. This is the final graph. I hope you got it. Have a look, see if there's any problem. All right, got it. Now I'll give you one graph. Plot the graph of this, but for this I'll have to tell you the graph of y is equal to x raised to n when n is, say, x raised to p upon n is greater than 1. Okay, so its graph is like this only. Okay, wait a minute, sorry, there's some change. I need graph of oh, that was right. I wanted this graph only, square and cube. Okay, yeah. Think about it. You need to start with this. Y is equal to x raised to 3 by 2. Okay, so I'll tell you this graph, because domain of this graph is only positive numbers. So this is like this. Okay, concave up. Whenever n is greater than 1, graph will be like this only on the positive side of x-axis. This is the graph of x raised to n, where n is greater than 1. Now it might be 3 by 2, it might be 3, it might be 5, it might be 5 by 2, it might be 7 by 2. Okay, so for positive side of x-axis, graph will always be like this. Whenever graph of y is equal to x raised to n when n is greater than 1. The graph might be on the left side of x-axis, y-axis also. Depends if those points are in the domain. So because that is not the case here, so I'm not discussing it because domain of x raised to 3 by 2 is only positive real numbers. So this is the base graph which you need to use to plot this graph. Okay, now let me tell you, you need to start with this graph. Y square is equal to x cube. Okay, so how to plot y square is equal to x cube? If you simplify this equation, you get y is equal to plus minus of x raised to 3 by 2, because whenever you take a square root, you need to put plus minus. So you already know the graph of y is equal to plus x raised to 3 by 2. This is plus x raised to 3 by 2. And what is the graph of minus x raised to 3 by 2? That will be like this, x raised to minus 3 by 2. So actually y square is equal to x cube. Graph of y square is equal to x cube is like this. Okay, so that is the base graph. Y square is equal to x cube. The graph of this function is like this, both the parts. It is not a function. Anyways, whatever relation is, we need to plot it. Got it? Now see, it's very simple. Here you have replaced x, you have multiplied fx to a constant 4. Okay, so whenever you multiply fx by a constant, you know what happens? The graph expands along y-axis. Okay, so if even after expanding, if I plot both the graphs simultaneously, then you can see the change. This is the graph of square is equal to x cube, and y square is equal to 4 times of x cube will have the same shape, but values will be increased along positive. I mean, graph will be expanded. Okay, this is the graph of y square is equal to 4x cube. So this is the transformation first. Now second transformation is, you can do both the transformations simultaneously. Replace x by x minus 3. So graph will go shift towards right by 3 units, and also replace y by y minus 2. So graph will shift towards up, any upwards, by 2 units. All right. Okay. So how would this new graph will look like? Okay, let me tell you. So graph is this graph, yellow graph. This yellow graph is going to shift by 3 units towards right, positive x-axis, and 2 units along negative positive y. Okay, so this point is going to be now 3 comma 2, and this graph will look like this, like this, and like this. Okay, so this is the graph of y minus 2 the whole square is equal to 4 times of x minus 3 the whole cube. So I hope you've got it. Have a look. All right, so in next session we will continue graphs of modulus functions. We'll put mod on x, we'll put mod on y, we'll also put mod on f of x, and I'll see how these graphs are transformed. Then after that we'll do fractional part x and greatest linear of x. All right, so now it is going to be very interesting after this. So before going ahead, you need to learn these 6 transformations which I've taught you in these 2 sessions, first and second session. Learn these all the transformations properly, and then we will put mod, greatest linear, and fractional part. Okay, we'll see how these graphs are transformed after that, and signum also. All right, signum. So we'll put all these piecewise defined functions. All right, so you guys, yeah. All right, so subscribe the channel, Let's Crack JEE, and like my videos if you're enjoying it, and use my code JEET1 if you want to get the subscription. So I've told you there are 2 kinds of subscription on Academy. One is plus subscription, another is iconic subscription. In plus subscription, you get unlimited access to the all the live classes to an Academy's platform, all live videos of any educator you can follow, and you can see all the educators, live sessions of all the educators who are teaching for IIT-JEE. And in iconic subscription, you get all the benefits of plus as well as personalized guidance. All right, an expert will guide you throughout your preparation. Okay, so I've told you about both the subscriptions, and even if you don't have any subscription, then you can attend special classes on the platform. Special classes are completely free. You can attend unlimited special classes on the platform. All right, so thank you very much for watching this video.